Welcome. We are going to solve exponential equations. This is an applications. We're going to do this graphically and algebraically. First, you need to stop, pause, get out course pack page 812. Course pack page 812. You also need to make sure you have your handy dandy calculator. Get that out as well. All right, so let's get started. Example 1, Brian's grandfather invested $150 at 5% compounded quarterly. The account was recently turned over to Brian, so that's $150 compound 5% compounded quarterly. At the time, the account contained $6,230. How long did Brian's grandfather invest the original $150? Step 1, model the situation using compound interest formula. Remember, the formula is y equals my original investment times 1 plus my rate divided by the number of times I compound to the number of times I compound to the nt power. N is the number of times I compound. T is the number of years, T. So I need to plug in what I know. Y is equal to the original investment times 1 plus my rate is 0.05. I compound quarterly, so that's 4 over to the 4t power. So that's my equation. What I need to know is I'm starting with, or I ended up with, $6,230. I need to find the amount of time it took me to get this. I want to solve this graphically, and I want to solve this algebraically. So let's start with graphically. Here's my calculator. I hit y equals to go to my equation. First thing I want to plug in is my right side, 150 times 1 plus 0.05 divided by 4. Close parentheses. That's going to divide before I add, so I'm good with that. I want to do this to the, open a parenthesis and put 4x power. That is going to do my equation for me. Now, my y2 needs to be the amount I want, $6,230. And I need these two to cross. If I hit graph right now, my window is nowhere near big enough to do this. So I'm going to hit window. My x's, I'm going to start around, let's do -3. I just need a number below 0 so I can see the y-axis. My x max, my x doesn't need to be too big. This is a certain number of years a grandfather is investing for his grandson. Let's do 15 for now. We might have to change that. Counting by ones is fine. Let me check my recording. Doing well. Okay. Sorry. Bring up my calculator again. My y's. I'm going to leave -10 because that's not going to make too much of a difference. That shows my x-axis. My y max. I have to go above 6,230. So let's go ahead and make that go to, let's just make it 7,000. And I'm going to go ahead and I'm going to count by 700s. And I'm going to hit graph. Now, obviously, my x's are nowhere near large enough. Check my equation. Okay, so I'm going to come back, and instead of doing 15 years, let's do 50 years. And let's graph. Obviously, my x's still aren't large enough, so let's go ahead and do 100 years. Now my x's are large enough. So one more time back to my window. My x's, I had to go up to 100, so I'm going to count by tens. And I see where they cross, so I can find where they cross. I'm going to go ahead and hit second trace. I want second trace to go to the calc menu. Number 5 is my intersection. 1, 2, 3. Enter 3 times. I get 74.994774. So that tells me that 75 years Right around 75 years is how long it takes me to do this. All right, now that's doing this graphically. We've done that before. What about algebraically? How does this work? Well, I have my equation is 6,230 is equal to 150 times 1 plus 0.05 divided by 4. If I plug that into my handy dandy calculator, I'm going to get out of this. This is 1 plus 0.05 divided by 4. I get 1.0125. So this is 1.0125 to the 4t power. Now remember, the way that this works is I need to get this t needs to be taken out of my exponent. And the only way I know to do that is logs. Based off of what I have here, since my power is 4t, my base is going to be 1.0125. So I need to come over to here and do log of 1.0125. Excuse me, log base 1.0125 of 6,230. I'm going to back up for 1 second. I apologize. Back that up. Before I do that, I'm going to divide by the 150 to get the 150 out of the way. Cancel that out. I get 1.0125 to the 4t power. Over here, I'm going to end up with 6,230 divided by 150 is 6,230 divided by 150 is 4.53333333. So this is 41.53 repeating, and I want to try to keep that as much as I can. Now I need to do my log. So I do log. My base is still 1.0125. Log base 1.0125 of 41.53 repeating is equal to log base 1.0125 of 1.0125 to the 4t power. Wow! Look! My log and my exponent cancel each other out. So on my right side, I have 4t. On my left side, I have this really ugly number of log base 1.0125 of 41.53 repeating. I can figure that out using my calculator, but before I do that, I'm going to come over here. I'm going to divide by 4. By 4. So that t is equal to, Paul, it's for station identification. Okay, so when I divide by 4, that's this big log, base 1.0125 of 41.53 divide by 4. So at this point, that's t. So I pull up my handy dandy calculator, and I'm going to go, well, remember, for this to work for me, I need to use change of base. So I need to do log base 10 of 41.5. Now remember, this was 3 repeating, so I'm just going to put a whole bunch of 3's in there. And I'm going to close that parenthesis. Those 3's are still going. Did I put too many parentheses? Oh, totally. But you get my point. Log of my argument divide by the log of my base, 1.0125. That's my numerator. And I want to divide that by 4. And hey, what do you know? Do these two numbers look similar? 74.99477397. I get the same 75 years. So I can do this not just graphically, but now I can also do it algebraically. I have 2 ways of doing these problems. Let's look at example 2. Travis bought a new car 10 years ago for $6,000. The car is now worth $600. By what percentage was the car depreciating each year? Model this situation with the decay formula. Solve for the percentage decay algebraically. Notice you do not need logs to solve. Let's check this. So I need to say it's depreciating. My vehicle started off, remember what I'm doing. This is y is equal to my original amount times 1 minus my rate to the t years. Okay. Let's see. So I'm going to come through here and say what I started with, what I ended up with is $600. Okay, thank you. Is equal to 6,000 times 1 minus my rate. That's what's missing. To the t power, where t is 10 years. Okay, so what I'm going to do here is I'm going to divide by 6,000. So I get 1 over 10 is equal to 1 minus r to the 10th power. Well, what do I do at this point? Well, I need to find what my r is. So I need to take the 10th root of both sides. At this point, I pull up my handy dandy little calculator. And I need to take the let's see, where did it go? Number 5. I need to take the 10th root of 1 divided by 10. I'm going to put parentheses in there just to be safe. 1 divided by 10. Oh, I missed the divide. Divided by 10. So that's the 10th root of 1/10. So now I have, slide this over here so I can see it. Shrink it down so it doesn't take up so much room. So now I have 0.794 is equal to 1 minus my rate. Well, I'm going to subtract 1 from both sides, and I'm going to get minus 1. And I'm going to get negative 0.2056. That's equal to negative r. So r is equal to 0.2056, or about 20.56%. So my original percent of decay was about 20 to 21% decay. Whoa, that's a lot of decay. But that's what the problem is. That's where I get this from. All right, let's go ahead and clone this page, or this part, move it down, and let's do example 2b. It says, wrong part, back over here. I want to extend page. If Travis's car depreciated at a rate of 12% per year, how long did it take before the car was worth $2,000? So now we're going to go back to the original information and say that he started at $6,000. 1 plus, or I should say minus, 1 minus my rate is now 0.12. And I want to find t now, because I want to know when it is now going to be worth $2,000. To find t, I want to go ahead and divide by 6,000. This becomes 1/3 is equal to 1 minus, well, what's 1 minus 0.12? Well, that should be 0.88 to the t power. Now, I keep hitting the wrong button. I can use logs. I want to get t out of the exponent, so then this is my base. So I'm going to do log base 0.88 of 1/3 is equal to log base 0.88 of 0.88 to the t power. Excuse me. Well, again, over here, the log and the exponent cancel, leaving t, and over here, log of 0.88 of 1/3 is going to be my answer. So I go back to my handy-dandy calculator. Remember, I have to do the change of base, so I'm going to do log of 1 divided by 3 divided by log, not natural log, but log of 0.88. And it tells me that it will take between 8 and 9 years for the value to reach $2,000. There we go. That's how we do that. That's been 16 minutes. We've got one more example. Example 3. During the first stages of an epidemic, the number of sick people is increased by 70% per day. On the first day, there were 40 sick people. How many days will it take the number of sick people to reach 2,000? Model this situation with a growth formula. Remember, my growth formula is y is equal to my original amount, 1 plus r to the t power. So this is y is equal to my original amount, 40, times 1 plus my rate as a decimal point, 70 to the t power. Now I want to know when I reach 2,000 people. So I want 2,000 to equal to 40 times 1 point, ooh, that's not a 3, 1.70 to the t power. Get my base by itself by dividing by 40. And this turns out to be, let's see what this turns out to be. Pull up my handy dandy calculator. I'm having little problems in my head. 2,000 divided by 40. And I get 50. So 50 is equal to 1.70 to the t power. I need to get that exponent, that variable, out of my exponent, so I have to cancel out the exponents. So I'm going to use logs. 1.70 is my base, so it's going to be the base of my log. And so now I'm going to go ahead and say log base 1.70 of 50 is equal to log base 1.70 of 1.70 to the t power. Once again, the log and the exponent cancel, leaving t. So over here, and I haven't been writing this out, but change of base is log of 50 over log of 1.70. That's my change of base formula, so I can pull up my handy dandy calculator. I'm going to go ahead and hit log of, no, I'm going to choose natural log. Does it matter? No. Natural log of 50 divided by the natural log of 1.70, and I get 7.37. 7.37. Now, one more time, let's talk about my epidemic. My epidemic is how many days will it take to get to 2,000 people? It will take 7 to 8 days for the epidemic to reach 2,000 people. There's my notes. There's my solution. There's my answer. Little over 20 minutes. I will see you in class tomorrow.